linear systems objective. By the end of this lesson, you should be able to solve a nonlinear system using substitution method technology. So nonlinear system of equations is a system with at least one of the equations is nonlinear. So remember, linear means the highest power is 1. So you get like y equals 2x plus 3, or x plus 2y equals 1. Those are all linear systems. So a nonlinear system is something with a power higher than 1. So like x squared plus 2y equals 4. Or x squared plus y squared equals 3. So the combination of these things makes this system a nonlinear system of equations. And there's lots of ways to do it. If I'm trying to solve a system that has this and this, one's a parabola, one's a straight line. So in this case, you could have the parabola and the straight line cross each other twice. You could have them touch each other one time and you get one solution, or you could not touch each other at all and you get 0 solutions. In case they're both a parabola, like right here is a circle actually. That's a parabola. So you have a circle and a parabola. It's kind of the same idea. They could touch each other 2 times, or they could touch each other 4 times, or maybe not at all. So there's like basically it's kind of a hodgepodge of how many solutions could you get when it's a system of nonlinear equations. We just go through and we follow the mathematics. So let's do our first example. You might have noticed I just changed the equation. That's because the last equation was disgusting. Anyway, let's talk about how to solve a nonlinear system by substitution. And first thing you should notice is by substitution, not elimination. That's because since we're doing a nonlinear system, sometimes elimination just simply doesn't work. If I give you a circle and a line, there's no way to solve that by elimination. You have to do substitution. This one here, we probably could solve by elimination, but substitution is a general standard here. So let's do substitution here. So if you notice, it's just like what we do in a nonlinear system. Like the method does not change if you do substitution, no matter which way you do it. I'm going to try to get a variable by itself, and I'll plug it into the other equation. So like here, we already have y by itself. Y equals x squared minus 4. So I'm going to substitute that in for the y in the other equation. And we get something like this. X plus the y, which is x squared minus 4 equals negative 2. Now I'm going to simplify this a little bit. I really can't add anything, so I'm going to rearrange it. So I have that. Now this is a quadratic. Remember the way you solve a quadratic? Is you set it equal to 0. And then you can either factor or use a quadratic formula. Let's add 2. X squared plus x minus 2 equals 0. Then we can factor this. This does factor. You get, right, 2 to multiply to get negative 2, but add to get 1, or positive 2 and negative 1. So x plus 2, x minus 1 equals 0. Split and solve. X equals negative 2 and 1. So those are my x values. Don't forget, you got to find my y values. So we go back up here, and we plug into any equation you want. So our x's are, what order x is? Negative 2 and 1. So when I plug in negative 2, when x equals negative 2, what is my y? My y is negative 2 squared minus 4, which is 4 minus 4, which is 0. So I have 1 point, which is negative 2 and 0. Remember, x comes first, y comes second. When I plug in 1 into my equation, again, you plug in any one, you get the exact same answer. I'll plug 1 into there. Y equals 1 squared minus 4. So y equals 1 minus 4, which is negative 3. So I get the points 1 and negative 3. So those are two places it intersects. And by the way, we could look at this by graphing. If I were to graph this is a parabola with the y-intercept of 0, negative 4. It's kind of like that. And then this guy, if I moved it over a bit, right, down to slope-intercept form, I start at negative 2 and I have a slope of negative 1, so down 1 over 1. The equation looks kind of like this. For this, I mean, graph's not perfect, but it's supposed to be at negative 2, 0. And this right here would be at 1, negative 3. So that's what it looks like that's what a nonlinear system of equation looks like. So generally solve by substitution. If you want, you could graph it and also solve it that way. It does work. But usually we just use it to verify our answer looks correct. Next one. This one I have a circle, which we haven't talked about that much yet. Let me talk about a little bit. And a line. So this one I could not do by elimination. It's just like not possible. There's no way I could multiply this by any number that cancels out the y there. So the only way to do this is by substitution. That's why substitution is so important and it's nonlinear. So we're going to do what we always do. Try to get a variable by itself. It's always easiest to get right? In this case, it's easy to get x by itself because move over that y. So I get x equals 2 plus y. And then we're going to plug that in for the x in our other equation. So we're going to have this. X plus y squared equals 4. We'll substitute in 2 plus y. Now the key thing right here is don't fall for the trap. Right? This is not 2 squared plus y squared. It's not that. What we do is we expand it. It's 2 plus y times 2 plus y. The rest of it stays the same. Plus y squared equals 4. So we got to distribute this. So 2 times 2 is 4. Plus 2y. Plus 2y. Plus y squared. Plus y squared equals 4. Right? This came from this simplifying this, and then this came from the y squared right there already. Out of like terms, oops, that should be y squared. So I'm going to get 2y squared right here. 2y plus 2y is 4y. And then that's a plus 4 equals 4. We want to set equal to 0, so subtract 4 from both sides. And we get 2y squared plus 4y equals 0. Now this I could factor in. It's actually like, it's not as bad as the other one, because I know there's only 2 terms, but that means what do they have in common? These both have a 2y in common. So I could factor out a 2y, and I get a y plus 2 equals 0. We could split and solve. 2y equals 0 is just y divided by 2. You just get y equals 0. And then y plus 2 equals 0. Subtract the 2. You get y equals negative 2. So we have 2 y's. I just gotta go back to my x. We'll just use this equation right here. So when y equals 0, right, we're just going to substitute into this equation. I get x equals 2 plus 0, so x equals just 2. So I have the point 2, 0. And then when y equals negative 2, substitute into this equation, I get x equals 2 plus negative 2, which is 0. So I get 0 and negative 2. Remember, x always goes first, y goes second, so I wrote it like that way. But those are my 2 answers. So I crossed at 2 points. Okay, let's do one last one. They want to solve the nonlinear system by graphing. So let's do a sketch behind that, because I can do it in the calculator. Okay, let's graph this guy. So that's an exponential growth. B is bigger than 1. So right, it's 1 times 2x plus 0. So I've asymptote by 0. And I cross that 1 above, and it's a growth, so it's like this. It's into that effect. Now let's look at this guy. This is the absolute value equation. So I'll move the y over, so let's add a y to both sides. And I get y is equal to x plus 2. We're going to graph an absolute value equation. Inside opposite, outside follow. So we're going to start at negative 2 and 0. And then your slope is 1, so we're going to go up 1 over 1. So they're kind of like this. It's like that. So I have actually I'm going to have 3 intersections. I was thinking 2, but this one crosses again up there. So I should have 3 answers here. What crosses up there, and then 2 points across it down there. Now, if I'm going to solve by graphing, I actually need a calculator because I'm not going to be able to solve that by hand. So let's put in our calculator. I just want to show you what it looks like and remind you how to graph those. So we're going to graph 2 to the x. And then down here. Now, I can notice how the calculator has y equals right here. So you cannot plug this in the way it is. You have to move it over and get the y by itself. If you're going to use your calculator to graph it, you always have to get y by itself. So absolute value, you could go do that here. You go to math, go over number, and then ABS is absolute value. X plus 2. If your calculator is updated, it looks like an absolute value. So you get that. Then we'll hit graph. We'll get something that looks like that. Right, so you can see the 1 right there, and it looks like 1 right there, but it's actually 2 right there. So we're going to find the intersection, so I can calculate, intersect. Let's find the one right here first. Hit enter a couple times, and you get 2, 4. So that point where they should cross is 2, 4. Okay, now let's find the ones down here. So second calculate, intersect, number 5. All you have to do is get really close down there. Right, so get close to that side. I can actually zoom in if I want to be sure about it, but I think it's good enough. And we get the point negative 1.6, negative 1.7, we'll round it to, and 0.3. Now I think there's one more intersection right there, so I'm going to try to find it. So second, calculate intersection. By the way, if you press up or down, that switches between which graph you want. That's all it does. First curve, first curve. I'll get a little closer to that side. And then I'll hit first curve, yes, and it jumps to the other graph and it says that second curve, you say yes. And then it's like, well, I'm going to guess, and yes. And then you hit enter, and then guess is for you. And there was 30 different ones. I'll give another one. Negative 2.2. And 0.213. So there we go for the 3 solutions. And that's the lesson.